this is equals mc squared, and it's that concept of the interchangeability between maths and energy. Um, yeah, they have energy, and in this particular case, they have energy in joules, the mass in kilograms, and the speed of light, which is that number there. Um, it's quite an incredible. It's 299,792,458 meters per second. Can you like even comprehend that? It's just crazy fast. Sorry, let me just have a drink of water. And at the bottom, it has the speed of light squared, and I'm not even going to try and say that number, all right? But it's just crazy amount of speed, all right, meters per second. And of course, you can change these numbers to either into kilometers or into miles and whatever, and reduce the actual number of digits that you would have to quote. But here's something really, really interesting, just to give you some idea of the mass, of the energy. If you could turn every one of the atoms in a paperclip into pure energy, leaving no mass whatsoever, the paperclip would yield 18 kilotons of TNT. That's roughly the size of the bomb, the atomic bomb, that destroyed Hiroshima in 1945. On Earth, however, it's not practical. There is no practical way to convert a paperclip or any other object entirely into energy. It would require temperatures and pressures greater than those at the core of the sun. I took this quote from, I think, Nova. So it just gives you some idea of the incredible amount of energy that atoms actually possess. So you, me, and the rest of reality, atoms, this was the closest I could get to my impression of an atom. It's just light waves spinning, all right? So I chose that one. And atoms together, we scientifically call substances like, hydrogen, sugar, whatever, just different substances. And then those substances in human cells combined look like that. And you can see it's an ecosystem. It's not just, one cell doing its thing on its own. It's a relationship. And this atom is a relationship. And here we have, and of course, these would be relationships with relationships, but here we have our organs. And of course, these are all, finely tuned relationships, all working together, composed of all those things. Then, of course, here we have a fish on a reef and the whole ecosystem. It's very, very complex relationships all functioning together. And then, of course, here we have a jungle. And I love this monkey vines or Tarzan vines. And all of this is ecosystems, it's relationships. And then, of course, we have our beautiful blue planet out in space. Everything is composed of connectivity, vibrations, cycles, motion and change, proximity, relationships, and the giving and receiving of energy, gravity, love, balances, and harmony. Change is the one thing you can count on. Everything's changing. Everything you do or don't do today results in your tomorrow. Change requires responsible effort. And that was brought home to me the other day when a friend of mine said, I've got land. You want to come and turn it into something, but you have to change what you're doing from writing and speaking and teaching and come and dig ditches. So it's interesting. I'm giving a lot of thought. Our rotating world. Now, it's really interesting that everything is cycles upon cycles upon cycles. Earth's circumference is 24,901 miles at the equator. If we went all the way around just at the equator, that's what it would be. Earth's speed of rotation is about 1,037 miles per hour on its surface at the equator. So it's spinning pretty fast. But that's the concept of relativity. Relative to the Earth, we are not going anywhere. We're pretty much standing still. So that's where the idea of relativity comes from. Okay, our elliptical orbiting world. Now, cycles upon cycles upon cycles, the same concept again. Here we are spinning in an elliptical orbit around the sun. The distance from the Earth to the sun is about, of course, it decreases when we're in the middle of the orbit, and it increases when we're at the extremes of the orbit. But on average, it's about 92,955,807 miles, according to the International Astronomers Union. Earth's orbit is 584 million miles per year. Now, that's a huge distance. Can you even comprehend that? It's a long way. Our Earth travels around the sun at approximately 66,627 miles an hour around the sun, which is really, really fast. I just got this image of the sun and the planets just to show you, that we have all of these different things in orbit. So Mercury is close to the sun, Venus close to the sun, then us in this Goldilocks zone, and we have a moon that's orbiting us, and then of course Mars, which is a lot colder than us, quite a bit further out. Then we have an asteroid belt in Ceres. We see as a star, but it's actually part of this asteroid belt, or it might be considered a planet in our days, because things change. So then Jupiter's orbit, it's like one of the gas giants, and he has Saturn, same thing. How physical things are is a relationship between the amount of energy they have, and of course, if they get too close, then they become hotter and hotter. So they won't be the same as this perfectly hard, more solid planet that we live on. But these are less physical. It's actually really interesting. Then Uranus and Neptune, and then Pluto out here, and it's got its moons, and Makey, I don't know what this is, like one that I'm not familiar with. And then of course the belt of objects out here, and Eris. These are pretty much found in recent years. Not Pluto, but these out here. So next one. Now, if you think of all of our motions and you combine them together as a solar system orbiting the sun, all of the planets are orbiting the sun as it flies through space. So it's a fascinating concept that here we have our cycles upon cycles upon cycles, and the sun doing its own cycles. So let's just go on to, and moving, cycles. You can see the cycles, playing themselves out. Then the Milky Way galaxy, the sun orbits the galaxy at about 448,000 miles per hour. So here it is going around the galaxy. The sun is about 25,000 light years from the center of the galaxy, and the Milky Way is at least 100 light years across from one side to the other. According to Stanford University, we are thought to be halfway out from its center. So halfway out. This is where they plotted it. The sun and solar system appear to be moving at an average rate of 448,000 miles per hour. At this speed, it will take 230 million years to travel once around the Milky Way galaxy. All right, so once around. Now, the thing is as we know from hurricanes and so on, this spinning is happening. The whole thing's turning. So how long will this spin as a galactic system? It's just really interesting. The speed of light, of course, is 186,282 miles per second, or 670,616,629 miles per hour. So 1 light year equals, 5878625370000 miles. That's a huge amount of distance that light travels in 1 light year. And the next one. The Milky Way galaxy is rotating with its huge spiraling arms, okay? It is flying through space at about 1.3 million miles per hour. So it's rotating at that speed around, and at the same time, it's flying through space. And at the same time, we are orbiting the galaxy. So think about that. Combine all of those spiraling, orbiting movements, cycles upon cycles, cycles upon cycles. The nature of reality is a symphony of cycles, vibrations of space, all flowing and moving together through space. It's symphonies of existence and life. It's symphonies of existence and life creating motions. Everything is like this magical symphony of motions and cycles and changes and seasons. And it's like all of the ancients who lived closer to the land didn't believe in linear time. It's only us that believe in the construct of linear time. I think we've lost the plot. Everything is cyclical and cycles upon cycles, and creating patterns and flows. And so, yeah, that's an interesting concept too, is if you took the whole galaxy with all of the solar orbits and all of those cycles, and you had to like plot all of those motions, you'd have this incredible combined symphony of flight through the galaxy. An ecosystem, love, relationships. Anyway, so that was what I prepared for today.